Hirakud is a multi-purpose dam built on River Mahanadi about 15 kilometers upstream of Spillway in Odisha. It is the longest earthen dam in Asia, having a total length of dam and dike 25.8 kilometers. It is a composite dam of earth, concrete and masonry structure. The main dam has an overall length of about 4.80 kilometer. The dam comprises of two spillways, namely, left and the right spillway. The left spillway consists of 40 sluices and 21 crest gates, whereas the right spillway comprises of 24 sluice and 13 crest gates. The design discharge of both the spillways is 42,450 cubic meter per second. The dam tow powerhouse is on the right flank of the main dam with an installed capacity of 347.86 megawatt. The project was commissioned in the year 1957. The design flood was revised from 42,450 cubic meter per second to 69,632 cubic meter per second. In order to safely pass the additional flood of 27,182 cubic meter per second, it was proposed to provide two additional spillways, one at the left dike with 5 spillway gates of size 15 meter by 15 meter each to pass the discharge 9,122 cubic meter per second, and another additional spillway at right dike with 10 spillway gates to pass the discharge 13,571 cubic meter per second. 2D sectional model studies were carried out for the original design, comprising of stilling basin floor elevation 151 meter and length 71 meter. Two modified designs for the energy dissipator have been studied. An alternative one comprising of stilling basin floor level elevation 151 meter and length 90 meter has been recommended, and further adopted the same for 3D model studies. 3D comprehensive model studies were conducted incorporating infrastructural facilities required for model studies in 50 meter by 50 meter model tray. The model incorporates existing main dam complex with left bank spillway, reservoir portion of about 1.5 km and river portion of about 3 km downstream of dam axis, proposed additional spillway with part of upstream reservoir, 2100 m long spill channel and Mahanadi River up to 300 meter downstream of confluence of left and right limb of Mahanadi River. Hydraulic model studies were conducted for assessing the approach flow conditions, performance of stilling basin, flow conditions along the spill channel and adequacy of its size. Detailed studies were conducted for various operating scenarios of combined operation of existing left bank spillway and additional spillway to decide the orientation of spill channel outfall joining the left limb of Mahanadi were conducted. Several modifications were recommended, namely, provision of curved guide walls to improve the approach flow conditions in front of end spans, and modification in the design of the spill channel at the drop structure by providing a smooth transition of the channel from 120 meter to 200 meter width so as to guide the flow smoothly. In order to improve the flow conditions at the confluence of spill channel and left limb of River Mahanadi, it was suggested to provide curved guide bunds oriented towards the downstream side so that the discharges from the additional and left bank spillways merge at the confluence tangentially without much disruption. Based on CWPRS recommendations, the drawings of the modified curved guide wall and the modified spill channel of uniform width of 120 meter and length of 1776 meter, supplied by the project engineers, were studied. All the modifications were incorporated in the existing 3D model. Studies revealed that the upstream approach flow conditions near the left and right training walls of the additional spillway in front of the first and fifth spans were accelerating away from structure and resulting in reduced effective waterway, resulting in unsatisfactory flow conditions. It was suggested to raise the height of the curved guide wall to elevation 193.68 meter for the design discharge. By raising the height of the curved guide walls, the approach flow conditions near the end spans was found to be satisfactory. It was observed that the flow conditions at the confluence of the modified spill channel and River Mahanadi were still not satisfactory. It was observed that the flow was spreading at 90 degrees at the confluence point and pushing the flow released from the left bank spillway toward the island formed between two limbs of the Mahanadi River downstream of the main dam during combined operation. CWPRS recommended to provide curved guide bund to improve the flow condition at the confluence. The studies for the finalization of the alignment of the spill channel to improve the flow condition at the confluence of the modified spill channel and River Mahanadi are still in progress.